In this exercise, I will walk you through the production calculations of a scraper operation. The contractor will utilize a Caterpillar 631E scraper, and its specifications are summarized in this table. We are also given its performance ripple and retarder charts, which I will show later when we will need them. For the moved soil, we are given the load factor, density, and rolling resistance rate. We are also given some operational information of the scraper, including the load time, the payload, dump time, and efficiency. The last pieces of information are related to the whole road length and grade. The scrapers will drive at a slow speed when accelerating and decelerating. In part A, we need to calculate the production rate of a single scraper. In part B, we need to calculate the number of scrapers to achieve a target production rate of 1000 bank cubic yards per hour. Our first step is to calculate the scraper loaded weight, which includes the scraper's own weight and the soil load weight. From the scraper specifications, we see that its empty weight is 96,880 pounds. The soil weight we need to calculate it is based on the planned payload and soil density. The payload is planned to be 90% of the heaped capacity of 31 loose cubic yards. However, we need to calculate the payload in bank cubic yards to match it with the production target. So we will multiply by the load factor that's increased by 10% to account for the scooping compaction that happens in the scraper bowl. We now can calculate the soil load weight to be around 70,000 pounds, and then add it to the scraper empty weight to get the loaded weight. The second step is to calculate the rolling resistance in equivalent grade percentage to be able to use the performance charts. We will transform the RRR value to equivalent rolling grade percentage using this formula as we derived it in the machine power lesson. We end up with about 2% rolling equivalent grade. The third step is to calculate the whole total time of the scraper when it travels loaded from the cut to the fill areas. We will use this table to perform our whole calculations over the different segments of the whole road. We have 5 segments, including an acceleration segment and a deceleration segment of 200 feet each. Each of these initial segments have an average speed of 6 miles per hour, regardless of the rolling and grade resistance. The other segments will have the same rolling resistance, but different grade resistances. We add up these values to get the total resistance, which is the greatest for the 4th segment. The time calculation follows the simple distance and speed relation shown, which I'm showing how to apply it for the first segment, which is the same for the last segment. Always be careful when dealing with the units. We are now ready to use the performance charts to get the speeds of the other segments, as all resistances are positive. So we don't need the retarder chart here, just the Rempel chart. We start using it by marking the scraper loaded weight on the top axis and drawing a vertical line. For the second segment, we mark 5% total resistance, intersect with the weight line, and draw a line towards the performance curves. We intersect with the 6th grade, which means the scraper will drive at 16.5 miles per hour. We calculate the time for the segment considering its length and speed. We repeat the same process for the other 2 segments. And we add all these segment times to get the total hauling time. The fourth step is to calculate the return time for the scraper when it travels empty from the fill to back to the cut area. We use a similar calculation table with the same whole segments. The first and last segments will have the same average speed and travel time that we calculated before. We calculate the total resistance values for the other segments, and we see 2 of them have negative resistances. For these 2 segments, we will need to use the retarder chart. We use the retarder chart as shown for the second segment with negative total resistance of 2%. We got that the scraper will drive on the 8th gear with a maximum possible speed of 33 miles per hour, which translates into 0.03 minutes of travel time on this segment. We complete the calculations for the other segments by using the Rempel chart for the 3rd segment and the retarder chart for the 4th segment. We add all these times to get 1.65 minutes total return time. The 5th step is to calculate the total cycle time by adding all these steps of loading, hauling, dumping, returning, and the maneuvering turns at the cut and fill areas. We add their values to get the total cycle time. Notice that we assume 0.21 minutes for the fill turn and 0.3 minutes for the cut turn. Please check the lesson video for more explanation of these values. The last step is to calculate the effective productivity using our famous cycle production formula. So we completed part A of the exercise with an effective productivity of 258 bank cubic yards per hour. In part B, we need to achieve a production target of 1000 bank cubic yards per hour. So the number of scrapers we need equals the production target value divided by the productivity of a single scraper. We conclude by finding that we need 4 scrapers in this operation to move 1000 bank cubic yards of soil per hour.